Okay, so we are trying to do well, before we studied the fact that, well, we actually started definite integral with that understanding. If you have a region of positive continuous function, then the region under the graph of this function, well, remember what we did here. We did estimated using rectangles, add up the areas of those ones, find limit, and we figured out that for the positive function, the area of that region is nothing but just integral of f of x dx. Now, what if I have two functions? I have, say, function f and g, and we go from A to B. Well, we can play the same game. We can try to figure out how to estimate the region between these two graphs. Well, and everything will go the same way. We split the interval to n equals subinterval. But now, instead of having a rectangle starting from x-axis all the way to the f of x, now our rectangle should start from one of the functions graph and go all the way to the other one. And in this case, the height, rather than being just f of xi, now it's going to be f of xi minus g of xi. Okay? And then you can complete that game that we played, and you will see that this region now, the area of that region can be expressed as one integral. Integral of, well, from A to B of upper function minus lower function. I'll just use this one, and if we do that, we are basically trying to find the region, the area of the region between the graph of these two functions. Upper function minus lower function. Why are we doing upper function, lower function? I'll add a little bit more details on that, but for now, you just want to go measure the height of your rectangles in your Riemann sum. And in this case, the rectangles will start from the upper function. It will go all the way to the lower function. And that distance, that height, is given by the upper one minus lower one. For example, I can write down this one and give you some time to form the integral at least. Find the area of the region between the graph of two functions, y f of x is 1 over x squared, g of x is 1 over x. On what interval? On the interval 1 to e. How about I give you 45 seconds? You sketch the graph of these two functions. You figure out what is the region, sketch the region. And more important thing here is that you figure out which function is upper function, which function is lower function. Okay? 1 minute, it should be more than enough. You're sketching those functions, and you're trying to figure out which one is upper, which one is lower. The interval are given, so you can write that integral for the area. Both of these functions, when I evaluate them at 1, I get 1. So both of them will cross the point 1, 1. Now, there is a difference between 1 over x and 1 over x squared when you're looking at x, positive x part. So both of them will decrease and go like that. But if x is bigger than 1, x squared is going to be bigger number than x itself. That means that 1 over x squared will go below the 1 over x function. So this is 1 over x. That's also going to go close to 1. This one is 1 over x squared. In the case of x is less than 1, between 0 and 1, actually they will swap. 1 over x squared is going to be bigger than 1 over x. For us, what matters is between 1, which we already figured out, that is the intersection point, all the way to E. That is the region we are trying to find area for. So in this case, the area is given by integral 1 to E of upper function, which is 1 over x, minus lower function. That is the key point for us, to write the area as one integral. And then, okay, evaluating this is another story. So you have to use FTC. Here I'm using FTC 2. I have to find antiderivative for 1 over x. That's ln of absolute value of x, minus antiderivative of 1 over x squared is negative 1 over x. So I get, and then we go from 1 to E. I found one antiderivative, and I need to plug in the endpoints. OK. Then let's just plug in the values. Ln E plus 1 over E minus ln 1 minus 1 over 1. Ln E is 1. Ln 1 is 0. So I have 1 plus 1 over E minus minus. So that would be 2 plus 1 over E. Evaluating that integral is a different story, again, than setting it off. But for me, the key point is that you see how I did set up that integral representing our area. Any questions, any comments? Yes, please.
Isn't this supposed to be 1 over E because positive 1 over x and then negative outside of the bracket, still positive inside?
Wait. You're right. Actually, I did put plus here. This is plus as well. You're right. And this will cancel out. Sorry. Update this thing. I made a mistake there. You're right. Thank you. It's the value 1 and negative 1 will cancel each other, and we will get 1 over E. Any other questions? Any other comments? OK. Before we move on, I have 2 remarks to write down. One is that upper minus lower, bigger minus smaller, when mathematically you want to handle that, the best way or the most fancy way to handle such thing is using absolute value. So, in other words, if I have, note that, if I have A minus B, absolute value of A minus B, it will always turn the values to larger one minus smaller one. Why? Because if this is bigger 1, a minus b will be positive, so a minus b will come out. So the first one will be larger. If b is larger 1, then a minus b will be negative number, and absolute value will spit out negative of that. So a bigger than b will be a minus b. B bigger than a will be b minus a. So in other words, that upper, bigger, minus, smaller, lower is always larger minus smaller always can be handled by absolute value. And that means that I can rewrite my formula, my area formula, this time a bit fancier. Using absolute value. Instead of writing upper minus lower, I can write it as absolute value of f of x minus g of x. I should add to this that, well, I will come back to this in 10 minutes, that is only fancy and nice way to write it down. When it comes to evaluate that integral, you have to get rid of absolute value. And to get rid of absolute value, you have to figure out which one is upper, which one is lower. So there is no run away from, at the end, you have to do upper minus lower. But this will give you always a good starting point, especially when we are grading your writing. That's one thing. The second thing that I should add here, remark 2. Remember the area under the graph of positive function? That is nothing but the area between the graph and x-axis. So area of the region between the graph of f and x-axis. If f is positive, we know that it's given by absolute value of f. But if it is not, you just need to follow this formula. You write a to b of absolute value of f of x minus 0. But minus 0, I don't need to write it down. So that's absolute value of f of x. Sometimes you will see people in the suggested problem saying, what is the total area of the region between the graph of this function and that function? That is, by that we mean really the area of the region between the x-axis and y-axis. So if you want to have more elaborate way of writing it, that would be integral of absolute value of f of x from a to b. Any questions, any comments? One of the interesting case that will happen is that you will notice the functions are intersecting each other, and they are creating this region without having any specific a and b. In other words, the region, they define a region by enclosing it. What does that have for me is that sometimes to find these limits, I have to work a little bit more things and figure out what are the intersection point. Points of intersection. In other words, not only, in some cases, not only you need to figure out which one is upper one, which one is lower one, but also you have to figure out the limits of your integral yourself by finding points of intersection. Let me write this example, and then you will. Example, find the area of the region enclosed by both functions. Y, I actually have two examples. I'll write just first one, and then we go from there. X squared minus 1 and y equals to 2x plus 2. And nothing more is given. The region is enclosed by these two graphs, meaning that these functions are going to intersect at 2 points, and you have to integrate the absolute value of f of x minus g of x from that starting point to the end point. How about I give you 45 seconds to sketch the graphs of these two and make sure that you see that, oh yes, these two functions, the graph of these two functions actually enclose a region, and figure out what would be the end points or the limit points for your integral. 45 seconds, you're sketching those two functions, and you're trying to find what are the points of intersection or the limits of your integral. Go ahead, please. Y equals to x squared minus 1. This is the parabola, goes shift parabola, the standard one unit down. And y equals to 2x plus 2. Go right. The region is here. Sketching that already tells you that, yes, these two functions actually will define a region by intersecting. Another thing that will tell you is that which one is the upper one, which one is the lower one. If you can sketch it, oh, wait a minute, I didn't sketch 2x plus 2, I sketched 2x. Oh my God. Well, the shape is very similar. I'll repeat that. Okay. I sketched 2x, now plus 2, so it will go up, I don't know how far. I will figure it out. It could be up like that or like that. For me, both doesn't matter. Oh my God, that looks like x plus 1. Let's say that's 2x plus 2, yes? Algebra will help us to figure out more details of that. And then, this is the region. Now, it says that, yes, the region is defined. We have to figure out points of intersection by setting them equal to each other. X squared minus 1 is equal to 2x plus 2. And that gives me x squared minus 2x minus 3 is equal to 0. And then, well, you try to solve this. Two numbers add up to negative 2. When I multiply, I get negative 3. So that is minus 3 plus 1. And set it equal to 0. That gives you negative 1 and 3. What it actually says is that exactly they will intersect at this point. At this point here. My sketching was a bit off there. Okay? And well, that means now I have area equals from negative 1 to 3. I will write the absolute value always to set the integral, but then when I'm evaluating, I'll get rid of it. So in this case, I say the upper one minus the lower one, absolute value. Well, I already did mention that the upper one is 2x minus 2, so we will get minus x squared plus 2x and then plus 3 dx. I have no other choice. When I want to evaluate that limit, I have to find which one. I have to get rid of absolute value. In other words, I have to figure out which one is upper one, which one is lower one. And this will give me minus x cubed over 3 plus x squared plus 3x and go from negative 1 to 3. Okay, what are the values here now? I have to figure it out. 3, that's negative 27 over 3, that's minus 9, plus 9, plus 9, minus. At negative 1, I have negative 1 over 3, another negative, that will be 1 over 3. This will be plus 1, and this will be negative 3. Yeah, these two cancel. Here I have negative 2 plus 1 over 3. That is negative 5 over 3. So the value, I will write it here, sorry, is 9 plus 5 over 3. Which gives me 27 plus 5, 32 over 3. Again, this evaluating that integral is a secondary concern for me today. What I'm using there all the time is FTC part 2. What matters the most is that set up an integral that gives you the area and then start evaluating. From that point on, everything will go on well. Any questions, any comments? How about you find the area of the region enclosed by y equals to sine x and y equals to cosine x. Only one of them. When you sketch it, you will see that they create these regions, infinitely many of them. What I am interested in finding the area of the enclosed region by these two functions, only one piece of that Should I give you 90 seconds to start this one at least yourself? Well, that's your 90 seconds. Please start. You are starting with the sketching, identifying the sketch of the region, and then going from there. Go ahead, please. That sine function this is cosine function. The region, at least on the interval 0 to 2 pi, you see only one of these complete regions. The other ones are half there, and you will repeat that. But first thing you should confirm that, yes, they intersect, they define a region, they enclose a region. Now, what are the endpoints? Okay, so I have to set sine x equals to cosine x, and I have to solve that. Well, I know that what makes cosine 0 is not an answer of this question, because wherever makes this one 0, this will be either 1 or negative 1. That implies that I can divide both sides by cosine. And I'm trying to figure out where tan is equal to 1 on the interval 0, 1. So points of intersection are wherever tan is equal to 1 on the, well, I need only to use one period here. The rest is going to be all there. And we know that tan is equal to 1 if, what are the values there? What are the values? Yes, pi over 4 is 1. What else? What else? Yes? You add a pi to that, that would be another answer, which would be 5 pi over 4. And yes, so in the interval 0 to pi, we are expecting to get 2 of them. And we have these ones. So now I can write the integral that gives me this area by just saying that, okay, the area is absolute value of integral of absolute value of f of x minus g of x. What are the limits? Limits of are the points of intersection. Okay. And then you try to evaluate that integral. Okay? I'll write one more step, and then I'll leave the evaluation of that integral to you. This writing area using absolute value has its own good things. It gives you one whole integral to evaluate. But when it comes to evaluating integral, you have to get rid of absolute value. And in this case, getting rid of absolute value means that you figure out which one is upper one, which one is lower one. In this case, we see that the sine function on that interval is upper one and cosine is lower one. So I will get sine x minus cosine x dx, and I don't need to write down anything more there. Done. Yes? Well, I mean, at least now I am at a step that I can use fundamental theorem of calculus. I will leave this one to you. If TC2, you do evaluate, the final answer you will get, or at least what I have in my notes, is 2 root 2. Hopefully that's the correct answer. Any questions? Yes, please.
How did you find the POI? Like, why did you know to use tan x?
Okay, I set these two things equal to each other. I have to solve this equation, yes? But then I know that wherever cosine x is 0, sine x will be 1 or negative 1. In other words, whatever makes the right-hand side 0 won't be an answer, a solution for my equation. That means that I can divide both sides by the right-hand side. I get sine over cosine equals to 1. That is the same thing as tan x is equal to 1.
And so you just weren't allowed to go, like, sine minus cos x equals 0.
That's also another way of doing it, but how do you solve it again? You have to turn it in something, yes? This is one way of solving that. Any other questions? Any other comments? Okay. Now it's time to cover the third remark. The third remark is not going to add much, but one fact that sometimes on the interval of integration, you may not be able to find one function is bigger than the other one. They may swap. For example, remark 3. Your functions might be of this form. What is special about those functions is that on this interval, f is bigger than g, but on this other interval, g is bigger than f. So what I wrote down as upper minus lower sometimes wouldn't make sense right away. However, absolute value of f of x minus g of x is always true. So this will still give you the area of the region defined by the graph of these two functions. However, when you want to evaluate it, you have to get rid of absolute value. And in this specific case, you have to go from A to the point that they swap which one is upper one, which one is lower one. And then you go from C to B. On each one, you will figure out which one is upper one, which one is lower one. So I will write upper minus lower, upper minus lower. Well, in this example, here upper is f, here is g. The from the, when you change the interval, your upper and lower changes. This is another time showing that the absolute value, which always will work, that area is always absolute value of f of x minus g of x. But to evaluate it, you have to break it down sometimes into several integrals. Why? Because you want to figure out on which subinterval which function is upper and the other way around. Yeah? Any questions, any comments for me before I write down the examples? Yes, please.
So if it was like the absolute value of sine x plus cos x, how do we like remove the absolute sign?
So you have to figure out where sine x plus cosine x is positive, where it is negative. So in that case, you're dealing with a completely different story. Yeah? Any other questions? Any other comments? Okay, let's then find the region, the area of the region. Area of the region between y equals to 1 over x, y equals to x over 4, x equals to 1, x equals to 3. "45 seconds should be more than enough for you to sketch the region and figure out how many integral you have to write down. In other words, how many times they will swap, which one is upper, which one is lower. That will give you the number of subintervals that you have to write. I'll give you 45 seconds to sketch it and see how much information you can get from that sketch. Go ahead, 45 seconds starts now. One over x, you sketch it like that. X over 4, or 1/4 of x, is this. Now, we are going from 1 to 3. Well, then the area, I don't need to know more details at this point. I'll say go from 1 to 3, absolute value of 1 minus other 1. That is a correct and an essential step for your solution when you're trying to find the area. Integral of absolute value of the difference from 1 to 3. However, to evaluate that, you have to get rid of absolute value. And that's where comes in this point, where there's swap, which one is upper one, which one is lower one. How do you find that point? That point, you can find it by setting them equal to each other. And that gives you x squared equals to 4. X is equal plus minus 2. Oh, we were expecting that, yes? Because, expecting that they will intersect in 2 points. But one of them is what we need to know here. Now, I can write my integral as go from 1 to 2 plus from 2 to 3. Separating those two tells you one thing right away, that, okay, Now it's a good chance for me to get rid of absolute value. How? From 1 to 2, I know that 1 over x is the upper one. So I will have 1 over x minus x over 4 for that part. From 2 to 3, I know that x over 4 is the upper one. So my absolute value integral will turn to x over 4 minus 1 over x. Does that make sense? Does that make sense? Yeah? Well, you now have all the knowledge to complete that calculation because everything is in place. You already got rid of the absolute value. So then you have to apply FTC2. Do it yourself. Let me see what is my final answer. Oh, my phone died. I don't have final answer even. That one also do it yourself. Yes, please. See, here, these are addition. Doesn't matter if I write this one first, this one. What matters is the integrand, the order of the difference. I have to always write the bigger one minus the smaller one, or upper one minus lower one. Yes, please.
Instead of like, so you know how we swap the variable number, can we like say like an absolute value?
That's exactly what I'm doing there.
No, but I said like in the equation, like, can you add a negative constant or not swap?
See, okay, what you're saying is that can I write negative here and write 1 over x minus x over 4?
Like when you use the like absolute value rule, I guess, yeah.
1 over 8x.
That's what we are doing. That's what we are doing there. That negative will be multiplied inside and change the order. That will make x over 4 to come first. That's exact. So what may be confusing there is that you're trying to apply the definition of absolute value, but turning upper minus lower, the remark 1, remember there, it's already applying the definition of absolute values. Okay? Any other questions? Any other comments? I think I will stop here. We have one more example on this part, but I will start tomorrow with one example. And then there is another type of things that will help us to start doing some stuff. Come back tomorrow. See you all tomorrow. And we will do more stuff.